So this is the chapter 17 homework number 18, and it reads right here that a rectangular block of copper has sides of length 10 centimeters, 20 centimeters, and 40 centimeters. If the block is connected to a 6-volt source across two of its opposite faces, what are A, the maximum current, and B, the minimum current that the block can carry? So since we know that we're trying to find current, which is I, we can use Ohm's law, which states that voltage equals I times resistance. And modifying that equation, we can get I equals V over R. And for R, we know that R equals P over L over A. So we're going to plug this in right here when we use our equation. So also flipping ahead a few pages, it had a table of the resistances of a couple elements. And I found that copper has a resistance of 1.7 times 10 to the negative 8. So it gives us 3 corresponding side lengths, but it doesn't specify which side length corresponds to which side. So I just drew a diagram here with side lengths, but it doesn't really matter because we still have to find all 3 variations. So the first variation for L over A, we can see here that we can make our length here 40 centimeters, and then our area, which is, an area of a rectangle is the base times height, 10 times 20. So this would be our area, and this would be our length for the first example. So I plug those in. So for length, we have 40 centimeters over 10 centimeters times 20 centimeters. So we get 40 centimeters over 200 centimeters. And that can simplify to, 1/5. And since this is in centimeters, we need to convert it into meters, so we get 1 over 0.050 meters. So doing the same thing for the other 2 sides, we can see that our length for another one can be 20 centimeters, and the area would be the side of 40 centimeters times 10 centimeters. So plugging that in, we get 20 centimeters over 400 centimeters, and that, be simplified into 1 over 0.20 meters, because again we have to convert into meters since it's given to us in centimeters. And then for the last one, we can make 10 centimeters our length instead, and then 48 times 20 as our area. Plug those into the equation, we get 10 centimeters over 800 centimeters, which can simplify to 1 over 0.80 meters. So since it asks us for the maximum current and the minimum current, we're going to use the maximum, like the highest value and the lowest value out of our 3 values that we found. And I put hearts next to them because I felt like it. And the 2 values, our highest one would be 1 over 0.80 meters, and our lowest being this one. So in order to find the maximum value, we plug everything in together. So we found earlier that I equals V over R. So the maximum value, we would plug in the 6 volts for our voltage, our copper resistance, which is 1.7 times 10 to the negative 8th, and then we're using this equation. Put this as here, okay? And then our L over A, which we found was 1 over 0.80 meters. So we know that with algebra fractions, if we have this value here in the denominator, we can put it to the numerator and multiply them. So it becomes 6 times 0.80 meters over our copper resistance, and we get this value, 282352941.2 amps. Yay. So we do the exact same one for the minimum. So we plug in our values, our voltage times our resistance times what we found for L over A. And we can put this to the numerator, so it becomes 6 times 0.050 meters all over the copper resistance, 1.7 times 10 times to the negative 8th. Plug that into your calculator, and you should get 1764705.82 amps. And that's how you do number 18. Thank you.